In the modern construction industry, building information modeling, also known as BIM, has become a transformative force across all disciplines. For structural engineering, BIM has revolutionized the way professionals design, analyze, and manage structural systems throughout the project. Gone are the days of purely 2D drawings and disconnected workflows. BIM introduces a collaborative, data-driven environment that enhances accuracy, efficiency, and coordination in structural projects. But before we proceed further, please consider subscribing and hit the notification bell for you to be updated on the latest structural engineering videos like this. BIM is not just a 3D modeling. It is a process that involves the creation and management of digital representations of physical and functional characteristics of a structure. A BIM model is a rich, intelligent database that integrates geometric data with material properties, analysis parameters, and construction information. It provides a shared knowledge resource that supports decision-making from the earliest conceptual stages through design, construction, and eventually operations and maintenance. In structural engineering, BIM supports the modeling and documentation of structural systems, including beams, columns, walls, slabs, foundations, and reinforcement. These models are more than visual representations. They include detailed attributes such as material type, strength, connection methods, and load capacity. The benefits of BIM in structural engineering are: 1. Advanced 3D modeling of structural systems. One of the fundamental advantages of BIM is its ability to generate precise and detailed 3D models. Structural engineers can model all the load-bearing components with exact dimensions and positions. These models reflect real-world behaviors and are directly linked to analytical models, which helps in understanding how the structure will respond to various loads and forces. Using software like Autodesk Revit, Tekla Structures, or Bentley STAAD, engineers can model steel and concrete structures with high accuracy, automatically detect inconsistencies, visualize complex connections and load paths. This leads to fewer errors, better design decisions, and clearer communication with stakeholders. 2. Integration with structural analysis and design. BIM workflows support seamless integration with structural analysis and design software. Engineers can export a structural BIM model into programs like ETABS, SAP 2000, or Robot Structural Analysis, where detailed structural calculations are performed. Once the analysis is complete, the results can be fed back into the BIM model. This integration creates a bi-directional workflow, enabling synchronization between design and analysis, real-time updates to member sizes or reinforcement based on design requirements, reduction in redundant tasks and data re-entry. 3. Clash detection and interdisciplinary coordination. Structural engineers often face coordination challenges when working with architects and MEP engineers. BIM addresses this through clash detection capabilities. For example, a duct passing through a beam can be automatically flagged, allowing teams to resolve the issue during design instead of on-site. Software such as Navisworks is widely used to detect spatial conflicts, schedule model reviews, and track design changes across disciplines. This proactive approach reduces the risk of costly errors and delays during construction. 4. Automated documentation and drawing production. BIM drastically improves how construction documents are produced. Once a structural model is created, engineers can automatically generate general arrangement drawings, reinforcement details, section views and schedules, quantity takeoffs, and bills of materials. What sets BIM apart is that these drawings are directly linked to the model. Any change in the model automatically updates all related views and documentation, maintaining consistency and saving time. 5. Improved construction planning and cost estimation. With BIM, structural engineers can contribute to more accurate project timelines and cost estimations. Quantities extracted from the model can be used for cost planning, procurement, and logistics. BIM also supports 4D, time-based, and 5D, cost-based simulations, providing insight into construction sequences, Material lead times. Installation durations. This leads to more predictable construction outcomes and better collaboration with contractors and project managers. 6. Lifecycle management and facility operation. BIM models serve as a valuable asset even after construction is complete. By integrating the structural BIM model into facility management systems, owners gain better control over building operations, reducing long-term costs and improving safety. 7. Sustainability and optimization. BIM enables engineers to test multiple design alternatives quickly, evaluating both structural efficiency and environmental impact. For instance, using BIM tools, engineers can optimize material usage, minimize waste and embodied carbon, analyze energy performance in collaboration with other teams. This supports sustainable building practices, increasingly demanded in today's industry. Several software platforms are tailored to structural BIM workflows. These tools support open standards like IFC, industry foundation classes, making it possible to exchange models across platforms. Looking ahead, BIM is expected to become even more powerful with advancements such as AI-driven design and optimization, generative modeling for structural systems, digital twins enabling real-time performance monitoring, cloud collaboration, enhancing remote work and version control. As these technologies mature, the structural engineering field will become more integrated, efficient, and innovative. BIM has fundamentally changed how structural engineers approach design and construction. From early conceptual models to detailed design, construction, and facility management, BIM is now an essential tool in the structural engineer's toolkit. As the industry continues to evolve, the adoption and effective use of BIM will remain a key differentiator for firms aiming to deliver high-quality, sustainable, and cost-effective structural solutions. If you enjoyed watching this video, please like, share, and hit that subscribe button. Thank you for watching.